For this project, um, you want to probably read and reread these three goals just to keep those in mind. Because if you get into the nitty gritty details of these directions, you'll start saying, wait, I'm doing a null hypothesis for what? You'll start forgetting what the end goal is. The first goal, are housing prices in your regional market higher than the national market average? Second one, is the square footage for homes in your region different than the average square footage in your homes in the national market? So housing prices is one variable we're studying. Square footage is another variable. Oh wait, sorry, this one over here. That's cost per square foot. So square footage is another. And then for region, what is the range of values in the 95% confidence interval of square footage for homes in your market? Okay, so let's see. They say your region. I'm okay if you choose any region, but it might be referring to you focusing on just your region. But with both of those, our goal is to compare a particular sample of 100 observations, and I'll show you how to do that again. We want to compare that to we want to use that random sample to compare it to the national average. So we need to know what the national average is. And unless they explicitly say it, I don't think they do. They don't come out and say it, so we're going to have to calculate the national averages ourselves. And that's not bad, okay? You'll probably want to do it through code, not from dragging and dropping though. So find an empty cell in Excel or Google Sheets. Type equals average to calculate the mean. Open a parentheses. And I'm going to type D6 colon, and if I scroll all the way down, D1005. You can actually just use these numbers, right? It'll be the same thing. I'm doing kind of the heavy lifting here. So it looks like, well, the mean home price is 123,000. That doesn't seem right. Oh, that's just for New England. Oh my gosh, so we got to do this through every. Okay, so that's tougher. They don't tell us the national average. I'll just calculate it for you. You can just use it from this video, okay? Because there's like commands you can use to get the average from each sheet. I don't remember them off the top of my head though. So let me pause the recording. What I'm going to do is I'm going to calculate the mean from each sheet. And because each region has 1,001 samples, I'm going to be able to add up all the means and calculate the mean of the means. So I'm going to help you find the national average right now. Means of each of the regions. And now this is a quick little statistics lesson. The only reason I can average the means of the means is because they're each equally weighted. They each have 1,001 data points. If one was only 100 and the other ones were 1,000, then the one with 100 is having more of an influence per house than the other regions. I'm able to take an average of the averages because they're all the same sample size. You just click and drag the last one, didn't I? Did I do that one right? Yeah. Okay. Okay, so the national mean housing price for the data set they were given, unless they say it somewhere else in the course that I haven't seen. This is my first time doing MAT, doing this new form of MAT 240 for SNHU. Looks like the average price is around $294,000 for a house across the nation, and the average square footage is around 1,954 square feet. Okay, so you're going to pick a region, and then you're going to take a random sample of that region like we've done before, a random sample of 100 observations. So this is just my scratch work over here. Let me get rid of that. Just a quick review of that process. If you need to take a random sample, one method is to do equals rand, open and close the parentheses, and then click and drag that so that it randomizes a number next to all of your numbers. Then we play the waiting game. Or we could play Hungry, Hungry Hippos, as Homer Simpson would say. Okay, so we got random numbers. Every time we do stuff, those random numbers are going to change. It doesn't matter though. We just want to right click on Excel. I think you have to click it, and then there's a button under Format, or I don't remember off the top of my head. I'm on a Mac right now. But there's a button under, I think it might just be a button that's called Sort, and then you want to sort it A to Z or least to greatest, whichever comes up. In Google Sheets, you can just right click and then sort sheet A to Z. It doesn't matter if it's least to greatest or greatest to least because they're random in the first place. And then if you take the first 100 values, you've got a list that's been randomized by a computer. So you've removed the human from the process of selecting your data. So I'm going to get rid of this. I'm really messing up Mid-Atlantic right now, but you could just do this in a separate spreadsheet. That'd probably be better. Like just paste that into a separate spreadsheet. So there, now I got housing prices, column A. I'm going to have to remember that. Cost per square foot, column B. And then the number of square foot in column C. So there's my random sample of 100. So I'll leave some of this for you to describe what's in your sample. Define two hypothesis questions. You'll want to define I can't give away the answer for that, but that's based off the questions that we have here. Okay, make a null and alternative hypothesis for this. Okay, think about whether that should be two-tailed or one-tailed, and then make a null and alternative hypothesis for this. That would be two hypotheses for that would be two hypothesis questions, and then you decide whether it's two or one-tailed test. Describe the population parameter which you're analyzing. Remember, that's the population number. Is it a proportion? Is it like a percentage as a decimal number, or is it a mean that you're trying to analyze with these numbers? Okay. Describe your hypothesis in your own words. That's just using common language. Describe the inference you'll use. Identify the test statistic. Are you going to use Z? Are you going to use T? Remember, if you don't know the population standard deviation, you've got to use T. And in most cases, it's just safer. The T distribution approximates the normal distribution under certain conditions too. So, level confidence, estimation, confidence intervals. Oh, so this is just where you give a summary of what you're going to be doing. You're going to use confidence intervals. Remember, confidence intervals. If your test statistic is in your confidence interval, then you can't reject the null hypothesis. You can't claim that there's a statistically significant difference. If that number is to the right of your confidence interval, then that means you can reject the null hypothesis. It looks like the mean home prices are bigger than the population mean because it's outside of our confidence interval. We think the true population mean is here under the null hypothesis, assuming that nothing's actually happening. And if it's beyond it, then that must mean we're wrong with our null hypothesis. It must mean there's something happening. It's probably way easier to say that than to realize what it means. I just have a decent understanding of it just because I teach statistics a lot. With a null hypothesis is something we have to assume. We assume that the status quo is going on, and then a researcher says, "Okay, I think this medicine's going to help, or I think this region has bigger than average home prices." That is the alternative hypothesis. You make your mathematical model based on the null, based on assuming that the person's innocent. And then you try to prove them guilty by gathering evidence for the alternative hypothesis, by constructing that confidence interval, and finding whether the population mean is in it or out of it. Okay, so if it's a one-tailed test, define your hypothesis. So like with these questions back up here, questions 1 or question 2, you got to decide whether those are one-tailed or two-tailed tests. Define your hypothesis statement, the parameter like we talked about, the null and alternative. Specify your significance level. I think they left it up to us to choose. They didn't say for these what significance level, so you could use 0.01, 0.05 is the most common. It's just kind of arbitrary. It usually depends on the situation. You'd use a low significance level, like 0.01, if you're trying to decide on whether to use a new medicine. Because that means you have to have really strong evidence to reject the null hypothesis. You got to be really sure the medicine's helping before you just start telling doctors to change their practice. We'd want to err on the side of caution with medicine, right? So that's why you'd want a null. We got a medicine that's sort of working. We would like something better, but we don't want to reject the old one and start using this new one unless we're really sure it's helping people. So that's a situation where you'd want a low alpha. And a high alpha, that would be like if you're trying to, it's usually studying like human science. You could use 0.10 if you're trying to decide whether a new social media platform is reaching to more people or something like that, because it's really hard to capture the effects of humans and especially their social interactions because there's so many variables there. I'm going off. Sorry. That's what teachers always do, and people get bored with that. Okay, so we got the null. You can go through these steps. Just this is repeating just what we set up above. You got to state your hypothesis. Data analysis. Analyze the data and confirm assumptions have not been violated. You want to make a histogram. Okay. But if your histogram is at least somewhat normally distributed, you can use a t-test for means. Okay. If you're talking about a population proportion, though, you don't need to do that. Okay. You just need to have a sample size that's sufficiently large. You don't need a histogram if you're trying to analyze a population proportion. If you're talking about a mean, though, got to make a histogram. Make sure it's at least somewhere near a bell-shaped curve. If it's skewed a little bit or if it's away, 100 data points is usually enough for the central limit theorem to comfortably kick in. So you'll want to probably talk about the central limit theorem too. Just say like we have 100 in our data sample. That's a relatively large sample size, so we assume that the central limit theorem means that the mean is normally distributed. Oh, and it says it right there. I didn't even read that. So make a histogram, summary statistics like you've done several times in this course: mean, median, standard deviation, shape, center, spread, and shape, just like before. Remember, the commands for median is equals median, and then your data goes here. Commands for standard deviation equals stdev.s. Data goes here. Oh, whoa, no, don't do that. Hypothesis tests. This is where you're going to calculate p-value, so I'll help you with this. It says determine the appropriate test statistic, but then it just tells you. Okay, so there's a big hint. You want to be using t. Okay. Okay, so let's say, oh, here, let me first show what the t-test is. You want to calculate a test statistic t, and then you can start using Excel and Google Sheets functions. T is found by taking the sample mean and subtracting it by the population mean, which is sometimes called the target mean in our course, as I found out, thanks to a student. And then you divide it by the standard deviation divided by the square root of n. It's kind of a mouthful there, okay? But the reason why we have all this weird stuff in the denominator is because now we're talking about a mean. So when you use when you're standardizing your variable, you need to divide it by the standard error of the mean. So let's do that with some numbers. Okay, so you go about your data set, you calculate a mean is, let's say we're doing the square footage part, okay? That would be answering this part here. Question 2 is about square footage at home. Let's say we got a sample mean, 1,500. And let's say the population, I don't remember what it was, what I showed you on the other screen. The population mean was 1,800. Let's say the standard deviation of my sample was, I don't know what it would be, 120 maybe. And then my sample size is 100. So my t value on scratch paper, I do 1,500 subtracted by 1,800 divided by 120 divided by the square root of n, which is 100. So I always do the square root first, but you can do the numerator of this fraction here. This is 1,500 subtracted by 1,800 is negative 300. And the square root of 100 is 10. So we're getting closer to getting that precious test statistic. 120 divided by 10, that's 12. And then we get t equals negative 25. Okay, huge test statistic. I just made up some numbers. That's why it's so big. Here, so let's actually fudge the numbers a little bit more. Let's say it's negative 2.5, something a little bit more reasonable. So the functions we found in Excel that they were telling us about was equals t.dist, and then there's a few options. Okay, RT means right-tailed, 2t means left-tailed. So if you're doing a right-tailed test, that's if you're testing to see if it's greater than something. If it's t.dist.2t, I think all you need is your t value, which is negative 2.5, and then your degrees of freedom. We had 100 for a sample size, so the degrees of freedom is just 99 here. Okay. Oh, it says number. Oh, I think this is the part where I had to look it up last time. Oh, it should be positive or zero. Uh, oh, because it's two-tailed. Okay, so if that happens, if you get a negative t-value, just use the positive version, take the absolute value of it. The reason is because if it's a two-tailed test, then the significance of 2.5 is just as far away as negative 2.5 is. So I guess for Excel, it can't accept negative values. I don't know why there's a dollar sign, but we got 0. That means it's really close to 0 for p-value. Let's say maybe let's just fudge the numbers a little bit more. Let's say you did all those calculations, you got negative 1.5. It's still 0. Maybe that's because, oh, that's why. Watch out for that. Okay, I copied and pasted, but Google Sheets was truncating the decimal. Here, I'll show you again. Equals t.dist.2t because I'm doing a two-tailed test. 1.5 because they want positive. They won't accept negative values. It started off like this. I had to add decimals to find my p-value. There's my p-value. That's relatively high, 0.1367. That's above 0.05, the typical cutoff. I would fail to reject HO, and I would say that my square footage for my region doesn't appear to be different from the national average because we can't reject HO. Okay, so I was doing a two-tailed test. You got to decide whether it's a one-tailed or two-tailed test. But you'll do the same process for both of those, part 1 and part 2. Excuse me. Okay. So part 3 asks us to construct a confidence interval, square footage of homes in your market. So take your data set and use the values from your data set to help you construct a confidence interval. Remember, to do that, you take your mean, your sample mean, and then you add or subtract the margin of error. That's found by doing t star. I'm going to write the word times, not confused with t star, times the sample standard deviation divided by the square root of n. Okay, and you can probably Google search a much nicer formula. T star times the sample standard deviation divided by square root. So with my numbers, my mean was 1,500. Wait, was this part 3? Range of values for square footage of homes. Yeah, so that's column C is my square footage, and I was pretending I got a square footage when I calculated. I was pretending I got 1,500. So plus or minus. Now the t star value for 95% confidence interval, everyone in the course is going to use the same t value. So I'm going to give it to you here in just a second, okay? T distribution calculator. I'm not using my test statistic. That was for testing a hypothesis. If I want a guaranteed 95% confidence interval, I've got to use the t-value from the book. I've got to type in my degrees of freedom, and I want a two-tailed test. So if it's 95% confidence, I want 0.025 in each tail. That way they add up to be 5%. So you could either use, you don't want to, yeah, it doesn't matter. You could use negative 1.984 because the plus or minus symbol will take care of it, or positive 1.984. So I need to multiply that by my standard deviation, which I just made up, divided by the square root of 100. So that's 1,500 plus or minus. I'm just going to double check with another calculator because I just thought everyone's going to be using the same one. What is X? What are they talking about? Okay, I don't know what that one is talking about. Let me do. We got 1.984. No, that's going in reverse. Oh wait, we could just go in reverse here. Yeah, 1.984 degrees of freedom 99. Yeah, okay. So this is 1.984 is the t value you're going to want to use. Okay, when we do this over here, do the denominator first. Square root of 100 is 10. and then do this, your standard deviation, divide by the square root of the denominator, which is probably a decimal number for you, and then multiply that to the t-value we got from our table, 1.984. So 23.808 is my margin of error. And so you do that once for addition, once for subtraction. So I'm doing 1,500 subtracted by my margin of error. And I'm doing 1,500 plus my margin of error. Okay, and there's my 95% confidence interval. But again, I made up these numbers. Everyone's number is going to be different because you're all doing a random sample from potentially all sorts of different regions. So what I would say for my confidence interval is I'd say, hey, the population mean is not in my confidence interval. That means I can say that there's a difference between my region and the national area. Okay, my region, I'm estimating the true mean for square footage is somewhere between these two numbers. So my region is lower than the national average. That's what my confidence interval says. Okay, this video is probably going to take forever to upload because it's so long. I hope that helps. That's the kind of technical details of what you need to do. I'll definitely help, though, if you're still stuck. If you think I missed something, please do feel free to email me. But imagine with a video this length, I'd put everyone to sleep by now.